This lesson, we are going to solve some few questions under vectors. So I have the first question on the screen here, which says what? We should find the angle between the vectors A and B. Okay, so with vector A being equal to what? I plus 2j plus 3k, and then vector B being equal to what? 2I plus 3j plus what? 4k. So I have to find the angle between these two vectors. So to do this, you can use the formula cosine of theta to be equal to the dot product of A and B divided by the magnitude of vector A multiplying the magnitude of what? Vector B. Okay, so you can use this formula here. When this angle here, okay, is the angle that's from when the two vectors are joined tail to tail or what? Head to head. So now, before you can do this, you have to find out the dot product first. So let's see how we are going to do that. So let's take this to be the vector A and then dot vector B, okay, which is 2I plus 3 3j plus 4k. Okay, so you have these two vectors and you have to take the dot product of these two vectors. So what you are going to do is that you are going to multiply each one of them. Okay, so I'll multiply this first value here, okay, which has the unit vector I attached to it by these two here. Okay, then I'll multiply this value also with this value, then I'll multiply this value also with this value, then I add all of them. So let's look at how you're going to do that. So this is how the dot product will be. So I'll multiply this one here by these two. So that was 1 times 2. And I'll multiply this 2 here by this 3. So that was plus 2 times 3. And I'll multiply this 3 here by the 4. So that was plus 3 times 4. Okay, so this will give me 2 plus 6 plus 12. Okay, and that will be equal to what? 20. This will be equal to what? 20. So that was A dot B. So this dot product is sometimes known as what? The scalar product. Okay, so if the question doesn't ask you to find dot product and it says find the scalar product, you should know that what it is the same thing. Okay, so now you know the dot product or the scalar product. So now what you have to find is the magnitude of the vectors. Okay, so for the magnitude of vector A, that will be equal to the square root of 1 squared plus 2 squared plus what? 3 squared. Okay, so let's see the value of that. So that will give me square root of what? 14. Okay, so now let's take the absolute value of what? Vector B, or the square root of what? Vector B. So to calculate for the magnitude of what? Vector B, that will be equal to what? 2 squared plus 3 squared plus 4 squared. Okay, so that will be equal to what? Square root of what? 29. Okay, so now that you know all these values, you can now calculate for the what? Angle between what? The vector A and then vector B. So that's what? Cosine of theta equals what? The dot product, which is what? 20, divided by the product of what? The magnitude, that what? With 14 times with 29. Okay, so now let's see what this will be. So we have what? Cosine of what? Theta to be equal to 20 divided by square root of 14 times square root of what? 29. That will equal to 0.993. Okay, so we are going to take the cos inverse of this value and then that give us the angle between the two vectors. So theta will be equal to what? The cos inverse of 0.993. Okay, so now let's see what you will get for that. So the cos inverse of 0.993, that will give me a value of what? 0.118. Okay, so I'm going to make this as theta equals what? 0.12 radians. Okay, this will be the answer in radians. If you want your answer to be in degrees, that will be equal to what? 6.7 degrees. So this will be the angle between the vector A and then vector B. So let's move on to the next question. Okay, so this question is to find the area A of the parallelogram with what sides A, which is equal to what, I plus 2j plus 3k, and then B, which is what, 4i plus 5j plus what, 6k. So you have to find what the area of what this parallelogram. So to calculate for the area of a parallelogram, the area A will be equal to what, the magnitude of what, the cross product of vector A and then vector what, B. So when you take the cross product of vector A and B, then we take what the magnitude of what the vector that we will get, and that will give us the area of what the parallelogram. So now let's look at that. So to take the cross product, we are going to use the determinant method. Okay, so I have I, J, and then K here. Okay, so the first value is 1. I have 1, 2, and then 3. And then I have 4, 5, and then 6. Okay, so now we are taking the cross product, okay, A cross B. So that will equal to what? When I take the first unit vector here, okay, that's when I'm considering this unit vector here. That will be this bracket multiplying this unit vector here. Okay, so that means I'm taking this first column here. Okay, when I take this first column here, then I'm going to ignore everything that's on this column. Okay, then I consider the remaining column. So I'm then going to do cross multiplication here. So I'll multiply this 2 by this 6, and then I'll multiply this 3 by this 5. Then I'll subtract the value of what, 3 by 5 from what, 2 by 6. So that what, 2 times 6, that'll be 12. Okay, minus what, 5 times 3, that was 15. Okay, so this is what you have now. Okay, then plus another bracket, then bring the g. So when you bring the g, then I'm considering what, the middle column here. So you are going to ignore the values there. So when you do this, I'll have what, 1 multiplying 6, and that'll be what, 6, minus what, 3 multiplying 4, that's what, 12. That's 6 minus 12. Okay, and then plus. Okay, so now I'm taking the third column here. So I'm going to multiply 1 by 5, and then that what, 5, and then minus what, 2 by 4, that's 8. 8. Okay, so now let's see what you get now. This will be equal to what, 12 minus 15, that what, minus 3i. Okay, and then 6 minus 12, that what, minus 6g, and then 5 minus 8, that what, minus 3k. Okay, so now this is what I have now. So this is the vector. Okay, so after taking the cross product, this is the vector we got. So now let's find the magnitude of what, the cross product. So that will be equal to what, the square root of 3 squared k plus 6 squared plus 3 squared plus 3 squared. So now let's see what you get for this. So this will give me 3 squared plus 6 squared plus 3 squared. So that will be 54. Okay, so now let's take square root of what, 54. So that give me 3 square root of what, 6. So this will be the area of the what, the parallelogram. So first of all, the first thing you have to do is what, to find the cross product of the vectors. Then after that, you come and find the magnitude of the vector that you get after taking the cross product. So now let's look at the next question. So this question, you have to find the unit vector in the direction of the vector 2i minus j minus what, 2k. Okay, so to find the unit vector in the direction of what, this vector here. Okay, so to find the unit vector, okay, you can use the formula unit vector equals what, the vector, okay, that's vector u divided by what, the magnitude of the what, the vector. So you can use this formula here to find what, the unit vector, okay, in the direction of what, this vector here. So now you know that the vector here, that's u equals what, 2i minus j minus what, 2k. So that's the vector. So let's find the magnitude of this vector. So that will be equal to the square root of 2 squared plus 1 squared plus what? 2 squared. Okay, so this will be equal to what? 2 squared is 4 plus 1 plus what? 4. Okay, so that will be equal to what? The square root of what? 9, and that will be equal to 3. Okay, so now we know the magnitude of what? This vector here. So now we now have the unit vector to be equal to what? U, and U is what? 2I minus what? J minus what? 2K. Okay, so what divided by what? The magnitude, which is what? 3. So then you have what? The unit vector to be equal to what? 2 over 3I. Okay, minus what? J over 3. Let me make it 1 over 3J. Okay, minus what? 2 over 3K. So this will be the unit vector. Okay, so for you to know that your answer is correct, let's look at how you are going to test for that. So you know that the magnitude of a unit vector is what? Equal to 1. Okay, so now let's take the magnitude of what? This unit vector here. Okay, so that will equal to the square root of 2 over 3 squared. Okay, plus 1 over 3 squared. Okay, plus 2 over 3 all squared. So now let's take the magnitude of this. When you do this and you get 1, then that means our answer is what? Is correct. So 2 over 3 squared plus 1 over 3 squared plus 2 over 3 squared. Okay, so when I did this, I got the magnitude of the unit vector to be equal to what? 1. So that means what? Our answer is what? Is correct. So that's how to calculate for the unit vector in the direction of what? Another vector. So let's move on to the next question. Okay, so in this question, we have to show that what? This vector here is what? Is perpendicular to what? This vector here. So what that means is that these two vectors here, okay, the angle between them is what? Is 90 degrees or what? Pi over 2. Okay, that's what the perpendicular here means. So we know that what? To calculate for the angle between two vectors, we can use the formula what? Cosine theta equals what? A dot B, okay, over the magnitude of A multiplying with the magnitude of what? B. Okay. So what happens here is that we know that what? The vectors are what? Are perpendicular. That means what? The angle between them is what? Is 90 degrees. Okay, so we take cosine of what? 90 degrees to be equal to what? A dot B. Okay, divided by what? Magnitude of A multiplying with magnitude of what? B. Right. And the cosine of 90 is what? 0. So you have 0 equals what? A dot B over what? Magnitude of A multiplying magnitude of what? B. So now, when I do cross multiplication here, I'm going to multiply this 0 by what? The magnitude of A multiplying what? Magnitude of B. And this will give me what? A dot B to be equal to what? 0. Okay. And this will give me what? A dot B is what? Equal to 0. So now what that means is that when I take the cross product of what? Sorry, when I take the dot product of what? The vector A and B, I should get what? 0. So in this case, I'm going to consider vector A to be equal to 2I plus 2J minus what? K. And then I'll consider vector B to be equal to 5I minus 4J plus what? 2K. So when I take the dot product of these two vectors, it should be equal to what? 0. If I don't get 0, then that means what? The two vectors are not what? Perpendicular. Now let's look at that. So to take the dot product, that would what? 2 times 5. So 2 times 5 would be 10. Okay, plus 2 times minus 4. Okay, that what? Minus 8. And then plus minus 1 times 2, that what? Minus 2. So that what? 10 minus 8 minus 2. And this will be equal to what? 0. So therefore, these two vectors here are what? Perpendicular.